Hey guys, this time we're going to look at the Euler equation and the Hamiltonian, how to derive it. So last little clip we did this law of accumulation of assets, and so this time we're going to look at the actual utility function. So in the question we're given this standard utility form, and we're given this for the function, the intertemporal whatever, and so let's do it. For the Hamiltonian, it's always going to be a function of four variables: consumption, assets, time, and the funny v thing. And that's going to equal, just like the microclasses, that will equal the integral minus the integral sign. So c of t to the 1 minus theta over theta, 1 minus theta, e to the minus rho minus n plus, what is that, mu times the budget constraint, which is this boy right here, w plus a to the r minus n minus c. And the Hamiltonian is going to have two first order conditions: a derivative with respect to c that always equals 0, and a derivative with respect to a, which is always going to equal minus the shadow price, minus the first derivative of this guy. And then you also need to remember what is the transversality condition, which just states that in the end we're all dead. Assets times the value of the assets as time goes to infinity will equal 0, just to ensure that nothing is left over. They'll consume everything before they die, or before the heat death of the universe and the sun explodes. Okay, so let's solve it. With the first order condition, we take the derivative with respect to c, which up here we're going to get 1 minus theta over 1 minus theta times ct to the 1 minus theta minus 1, and then the e to the minus rho minus n just comes along for the ride, and that's going to be plus negative mu. I don't know. Which is going to simplify to this cancels, and this is going to be theta, so we get ct to the minus theta e to the minus rho minus n minus this equals 0, and so we can write that mu equals ct minus theta e to the minus rho minus n t. There's a t here, sorry. T. Don't do that on the test. And we're not actually interested, well, we are interested in the value of this thing, but we're more interested in the value of its derivative, because we need to eventually be able to solve this guy down here. So let's take the derivative of this, and we're putting a dot because it's with respect to time. So we have to remember chain rule, because c is a function of time. We're going to get negative theta ct to the minus theta minus 1 times c dot t. That's the chain rule. And then this is also a function of time, so we're going to have to do product rule too. It'll come along for the ride first, but then we need to add the derivative of the second times the first. And then this is just going to be, it's e, so it stays the same. And then chain rule, we're going to have a minus rho minus n fallout. Good. And then we simplify to v dot equals minus theta c of t to the minus theta minus 1 times c dot t e to all this minus rho minus n c to the t minus theta e to the minus rho minus n times t. And I'm out of space, so I will continue in the next little clip.